Today we're gonna, as a part of the HP and the City training sessions, we're actually gonna be looking at a few different Python development environments. We're gonna touch a little bit on Python code, but primarily we're gonna look at the different environments you can use either collaboratively or individually to work on some of those code sets that are so near and dear to this hackathon. Just to give a brief overview, as we do in all of these sessions, our agenda today, we're going to give some quick introductions, our hackathon objective, our deliverables and resources and general information. And then we're going to dive into those development environments. Now, even though I am focusing on saying Python development environments, that doesn't limit them to just Python. Some of these, like Ripplet, can actually do a variety of languages, including C++. Python itself, you can add additional extensions that could allow you to do R and Java and things like that, JavaScript and things like that. So don't think just because I'm targeting Python, because it's one of the most used languages, both in data science as well as during these events, that that's the only thing they can be used for. So if you're that JS person out there or the React person out there, please know that these resources are also out there for you with the addition of the appropriate extension. So just to, of course, let you know who the organizers are. We have Alex Nolt and Amy Cannon, Boyd Wilson, Dr. Linda Hayden, and myself, Jamie Powell. Now, both Amy and Boyd are here today. If you all wouldn't mind saying hi.
Hello.
There's Amy and Boyd. Apparently, he's splunking right now in his rock cave, as we can see. But we do want to let you know that we are here for you, and our contact information is, of course, there if you have any questions. We also have many of our mentors here that will also participate within the event, like Dr. Caldwell and Junyi Chua and Rich. And of course, Boyd is actually going to be a mentor as well. John, we may squeeze him in there to work as a mentor or a helper, and Edgar as well. And Josh along with them. Now, the objective of this hackathon is to take those resources and skills and knowledge that come along with the high performance computing group that are part of Supercomputing 20 and to apply those skills and techniques and knowledge towards the local region that the conference takes place in. In this case, even though this year is very unique in that it's a fully virtualized conference or a hackathon and conference due to the current COVID pandemic, we are still targeting our local region of Atlanta, which is where the conference would have originally taken place in person. We want to make sure you develop an understanding of Atlanta-based issues through the application of data analysis and presentation or management. And of course, you can expect learning these different techniques and knowledge, familiarizing yourself with data science in the cloud, collaborative software engineering, as well as things like presentation skills and group work. The deliverables, just to put out there, as we always do, to remind all the participants of what's expected of you, includes producing source code with comments in the source code. You'll see that in my code as well today. A PDF of your presentation, which you will, of course, be giving, that includes your team members, your use of HPC technology in the project, as well as regional or Atlanta-based implications of your project, how your project can impact the Atlanta area. And all of those things should reside within a GitHub repository that your team creates with a readme.md, so a readme markup file that gives a project description. And more information on how to do that was given in a previous training session. Some of the resources you'll have, of course, mentors, you'll have Slack for communication, which reminds me, if you have not yet joined our Slack channel, please send me an email and let me know so that we can get you up and going. Google Cloud, which you're going to see a little bit of Google Cloud today during our training session, and actually during next week's session, which will be our Cloudy Cluster session, you'll actually even receive some of your credit so you can go ahead and practice some of these techniques before. And of course, some of our most commonly used languages, in which case today we're going to focus in on Python and Jupyter notebooks. And we're also glad to say that a lot of our data sets, which you're also going to see today, I'm actually using one of those data sets, are available on our website, hackhpc.org. And thanks to Josh for that. And then our general information, the 3 T's. The 3 T's consists of teams, time, and topic. And so for teams, our teams will consist of 4 to 5 students with 1 primary mentor and 1 specialist or staff that will assist them. Your time frame would take place from November 5th through the 9th with at least 2 check-ins per day, excluding the first and last day, in which case the first day will include forming your teams and developing your project. The working days, you'll have 2 check-ins per day. As far as with as a whole with the group, it may be different depending upon what your group needs. And then the last day, you'll have your final presentations. And of course, we have a couple examples of some topics that you can choose. Right now, some of the buzz is, of course, going around social justice and the presidential election, because keep in mind, the presidential election will be taking place 3 days before, or actually 2 days before our event starts. So there may be some interesting happenings in the country during that time. So now we're going to actually get into our Python development platforms. Let's do a quick little overview. For Jupyter notebook platforms, quite commonly, most data scientists or professors and students that generally start off in the Jupyter notebook realm start off with a local installation. So in other words, software installed on your personal computer. And generally speaking, they lean to a software platform called Anaconda. And the reason they do that is because it allows all of the general modules and libraries, which I'll tell you about here in a moment, to be installed, as well as it gives you access to a wealth of other platforms that you can use. The Google Cloud AI notebooks, which we're going to take a look at today. It's also another useful tool. Now, in this case, it's actually called Jupyter Labs, which gives you a little bit more functionality, but it still uses that standard IPython notebook or Jupyter notebook methodology. It does require that you have Google credit, so there's a cost associated with it. Now, fortunately, as students, you all are actually given some Google credits for free. If you didn't know, you may want to take a look at your educational account to see that, but we will be providing Google credits for you during the event. There's also a little bit of a learning curve in that you have to set up your instances in order to use this particular platform, but it gives you the ability to modify the computational power that you have available to you. Collaborative platforms, or in other words, platforms that more than one programmer at a time can work on the same software. We're going to take a look at Google Colab, which is available to anyone that has a Google account. And it has connectors into Google Drive, so you can save your data sets into Google Drive and then work on them inside Google Colab. It looks a little bit different, and there is a little bit of a trick to use the Google Drive connector or the Google Drive mount, but we'll take a look at that as well. And then we have Ripplet, which is more of a standard Python IDE in that it doesn't support IPython out of the box. There's a way to do it. I'm not going to look at it because it's a little bit convoluted and it's a bit of a hack to get working. But the standard Python commands do work inside of Ripplet, and Ripplet also allows you to use other languages very easily, like C and C++ and JavaScript and things like that. Now, there are many, many other development environments out there. Many. VS Code, Atom, Spider, Thonny, PyDev, IDLE, and the list just goes on and on and on. So the fact is, what you need is going to be up to you. I just want to give you a couple that I've seen used during these events so that you're aware of them. Now, I want to go over the sample code just a little bit, and I'll do this again once you see it. But what our sample code is actually doing, so a standard Python 3 code. So Python is a scripting language. Inside of that scripting language, we use these things called libraries or modules. We kind of use them synonymously, but we're going to use the modules request, pandas, OS, and matplotlib to, in respect, requests actually allow you to pull information from websites. So we're going to be doing that to get our data set. Pandas allows us to work in things called data frames. It's specifically made for utilizing or working with different data sets. Data scientists use it a lot for manipulating data sets and things. OS is exactly what it sounds like. It allows us to run commands on your local operating system. No matter what that operating system is, it adjusts as needed. One example is we're going to use the command list directory. For a Mac or a Linux machine, I'd use a command called ls, list, to actually list a directory, wherein on the Windows side, I would need to do a dir. Well, the OS module or library actually takes care of that for us. And then we're also going to use an extension of the pandas module called, but it's its own module as well, called matplotlib, to do a very simple plot there. Now down the bottom, we do have our code set listed, but that was also included in the email you received. And it's also listed on hackhpc.org. So if you'd like to download these sample code sets that I'm going to use today, please feel free to do it so you can play the at-home version. All right, and thank you, Josh, for adding that information to chat. So may the odds be ever in our favor as we demo. So let me go ahead and escape out of this. We're going to stop our share, and we're going to switch over to our other shared screen. Now, I do want to warn everyone that is participating with me today that demos can sometimes be interesting. Even though I've taken the time to make sure that everything was up and running today, that doesn't necessarily mean that it's going to work as advertised, because it's a demo and Murphy's Law is a thing. So we're going to give this a shot. Now, the first platform that I'd like to tell you about is Jupyter Notebook using Anaconda. Now, I've already started up Anaconda in the background, and I've selected Jupyter Notebook. And when you start Jupyter Notebook, you're brought to this screen. What this screen is actually a representation of your file system on your personal computer. Having said that, so you see desktop here up at the top, and I'm going to blow this up a little bit so you can see it a little bit better on your screen. There we go. And inside of my desktop, I downloaded my sample code to a file called Jupyter Training. And inside of Jupyter Training, I have a file here called local Conda Jupyter version. So if you have Anaconda installed on your computer at home, you can by all means select local Conda Jupyter version and go and modify this file. If you do not have it installed, that is okay. You can always come back and install this, and all that information is provided, of course, on the slides. This installation does take a little bit of time, so be patient. But I have clicked on my Jupyter Notebook, my local Conda Jupyter version, and here we are inside of the world famous Jupyter interface. Now, I want to give you a little bit of a quick runaround so that you understand what's going on here, a little bit of an overview. There are basically two types of cells that operate within Jupyter. One is called a markdown field. You can look at this as being like a text field. and the other is called a code field. This is a field where you can actually enter code and then run it. Now, there's something else that I want you to be aware of, something called a kernel. A kernel very simply means the type of software that you're running at the time. So in this case, I am currently running Python 3, but this easily could have been R or Python 2 for whatever reason, or any of the other different software platforms, generally scripting languages that you make available to your particular instance. Inside of the markdown field, that text field, this is going to look very similar to that markdown we use for Jupyter inside of GitHub for our readme.md file. That's because they're both using that markdown scripting language. Now, as you can see here, up at the top, this hash and then space and then a name means we want a header file. I have two little stars here next to purpose because I want it to be bolded. I have some plain text, a little line going across, a divider, header 2, and then some bullet points. And the way I run this is I can click run here at the top, or I can press the buttons Shift Enter. And as you see, it renders out that code into visible language. Now imagine if it is a hackathon event day and you've actually written code and you have an instruction set that you want to give to the users, or you have pictures that you want to display. This markdown language will allow you to add that information to your program, making it more of an interactive notebook. Imagine if your textbooks were written this way. Just putting it out there, just putting it out there. But then we also have our code blocks. As you see up at the top, it changed to code. And I have some basic Python code here. I'm importing the library called request. Request is a library that allows you to create, post and get HTTP requests, just as if you were on your web browser and you typed it in, and then it receives that information back in. And then I set a URL to a data set. Now I want to take a moment just to show you where this data set comes from. So this is a little bit of a sidetrack. If I go to our Hack HPC site that Josh has carefully curated for us, up at the top where we have participate, there's a section called data. Data. I'm going to go ahead and select that. And in this case, I wanted a local data set. And then I actually wanted to use the Open Atlanta data set, which is right here, Data Atlanta. And when I click on it, it takes me to the Atlanta data set where I actually created the data set that I'm about to use today. Again, I wanted to make sure I introduce this to let you know this is one of your resources that you can use. They do have tags that allow you to use different data sets, and this data set is ever increasing. So everything from the Atlanta Police Department to Airbnb information data, depending upon what your project requires. All right, let's head back over to our file here, our Jupyter notebook. So I set a variable equal to that data set. I actually have water data here. So that open data set actually took me to a USGS, so a US Geological Society data set. And I am just pulling data from the API, the application programming interface. So that's where all these different variables are here that are saying that I want all of this data beginning on the date of January 1st, 2020 and ending October 7th, 2020. So let me put this in an example methodology. I believe that there is some type of connection that we can see in the improvement of water quality because people aren't out and about. They're in their homes. So I'm pulling the water data from the USGS to test this example. And this area is specifically targeted the site number, is actually a site, a USGS site in Atlanta with a sensor that pulls information as quickly as every 15 seconds. So that's what this data set does. So I'm going to go ahead and run that just like I ran the text block before. I'm going to hit Shift Enter, or I could have quite easily hit Run. And over to the side, you're going to see that it says N4. That lets us know for a second it turned to an asterisk, and then that little number lets us know that it actually ran. I'm going to drop down to the next block, and I'm actually going to use that request library that I imported in the block before to pull information from that URL, from that website. And then I'm going to write it out to a file. So these are the two things that happen. So it goes to the website to pull this data set, and then it takes that data set, R, and opens it, and opens a file called atl-water-data.tsv, a tab separated value file, and it saves it to it, the content from R. So let's go ahead and run that. Now this is going to take a little bit more time. Remember, I'm pulling a large data set. So you've seen this cell has turned to an asterisk, and we're going to wait for it to turn to a number that lets us know that it actually ran. So that took a little bit of time. Now, I want to make sure that that file actually was created. Now, I could do the easy thing. I could go up to the top and go back to our file manager, and I can see that I have something here called ATL water data TSV, but no, let's do this in code. And the way we do that is we use a library called the OS library. So I import the OS library, and I use this command called os.list.dir. And all this does is it, from the current working directory where I'm sitting right now, it goes out and says there are these files available. And then I'm printing that out, and you see we have Jupyter Training, the DS Store, which is something from my Mac, but we do indeed have our atl-water-data.tsv. And now, just to prove it, I'm going to hit Run one more time. And sure enough, there we go. We have a few more things in there because I pulled my entire file set, but it does 100% let you know that I am pulling a local LS or a local DIR. Another way we could say this for people that are not used to command line, because some people may say that I've never heard of these terms. In Windows or Macintosh, you may, on Windows, you may click on your file manager and it shows you the files that are inside a folder. Or on a Mac, you may double click on your Finder and click on the applications, and it'll show you the files that are there. LS for the terminal, or DIR for the command prompt on Windows, does that same thing textually as opposed to visually. All right. We're going to go ahead and preview our file. So in other words, we're going to pull 45 lines out of our file and just print them. And that's exactly what it is. So this is the header, gives us information about where it came from, what the different parameters, the numbers mean. So in this case, one I'd like you to pay attention to is this dissolved oxygen one, which is 39628. And then you start to see the data set listed. Well, let's put that into a data frame. So this is a common method that data scientists use to view their data sets. We're going to use, and Pandas is by far one of the most popular libraries out there. If you're a Python programmer, there's about a 99.999% chance that you're going to use the Pandas library at some point in your career. I'm just letting you know. And you'll see why. It's actually quite powerful. Now, what I did inside of Pandas in this case is I read that CSV. I know it's a TSV, but I told it that /t, so tabs, are what separate each value. So it's a little trick of me being able to use this tab separated value that was given by the data set to read it in to this variable called ATL water df, df meaning data frame. And I also told it that the header is 35 lines long. That means that all in this preview here, all this stuff up here, I didn't want in my data frame. I wanted the actual data. One last little trick I did here is I dropped line 0, and that's because the header actually has 2 lines to it. So it has this with all the names, and then it has these numbers of how often they're taken. I didn't want this part where of how often they're taken, so I dropped it. And then I just printed out the first 10 lines of that data set. So you see we have our agency, our site number, and then there are those numbers that we have from our header that tells us what each one of these are. So we have a data frame. Moving on, and let me go ahead and run that. It's important to run your cells. One thing you're going to notice is I'm working my way from top to bottom, not skipping cells. And the reason I'm doing that is because we want to go in order of the cells. Imagine if I opened this up and I just jumped into a cell and ran it, but it required a library that was called on before it, or required a data set that was required before it. So in the case of this one, if I tried to make a data frame before I had the data available or before I had that file available, it's going to throw errors. So that's why I'm working my way down from the top to the bottom.
Can
And
I interject for a second there, Jamie?
Certainly.
It's really important when you're working with Python and in Jupyter Notebook. A lot of people like to change cells haphazardly, randomly, just to get something working. At the very end, before you publish your notebook, hit that stop button and then run the notebook all the way through just to make sure that everything is present in order. So yeah, a restart and run all is always a good way of making sure that somebody else can run your notebook before you ship it off.
That's a very good point. That's a very good point, Junyi. As you can see, it's very easy for me to jump into a cell and change something. And a lot of times people do that. And Junyi is 100% correct. You should always check before you're done. Check your file just to make sure everything's good to go by doing that kernel, restart, and run all. Very good point there, Junyi. Now I'm going to do something a little bit quick. So sometimes in our data sets are so large, we just want to have an idea of what's going on with them. That's another reason why I love pandas. As you see, I put my data frame name, ATL word DF, but then I use this dot method called describe to just give me an information of what is in this ginormous package of data. So alt.order.df.describe, I'm going to go ahead and run it. And if you see here, there are over 26,000, you might as well say 27,000 separate entries for this data set. Now, granted, in some people's minds, that's a lot, but I promise you there are data sets that are quite larger. But this does give us an idea of just how much data is within this data set. It shows us some frequency information, and it can, and most importantly, it actually shows us this information for every column here. So every bit of data that's here. So in my case, again, remember I told you, remember that dissolved oxygen, so that 39628_300. There are only 23,000 of that particular reading. Now that could have happened because the sensor had an outage. It could happen because that particular sensor didn't have as many readings as some of the other ones. This is something that can happen with data. It's something you kind of have to be aware of. And it's something you may have to deal with depending upon whether you need to remove those data sets that aren't there, so they aren't null or zero and throw off your averages, or set them to NA or null and just ignore them when you go through and process them. This is one of those data science questions, and don't worry, your mentors will be able to help you make some of those harder decisions, as they smile at me when I say that. Moving on to one last thing that this code does. We like pictures. We do. Me showing you this table up here with the data in it, yes, that was neat, but I have no clue what's going on in this data set. This little snippet of data gives me no full view of what's going on with 26,000 entries, or in the case of dissolved Ooh, back up here. The dissolved oxygen, 23,000 entries. We're visual people. And so we want to create a plot that allows us to see what was really going on. Now, this is a very basic plot. I will say that when you create plots, you should 100% add X and Y values. You should make it pretty. You should work with it. But if you just want to get a quick look into what is going on with this data set, this is a quick way for you to do it. What I did here is I added the library matplotlib. I made sure I didn't have any plots open. And then I actually plotted 39628_300, which is our dissolved oxygen column. So I used the name, the header name of the column in brackets and quotes because it's a string to pull that information out. Now there's one other catch that you really need to be aware of when you're pulling data from files. It considers everything a data type of strings. Now, for those that aren't coders, strings, the difference between strings and numbers, like integers or real numbers, is the fact that strings are just text. They have no real value. We have to tell the data set that, hey, this thing you think is a string is actually a number. And the way we did that in this case is we used the dot method called PD2numeric, and we applied it to that data frame. There's more information about this on the Pandas site, as well as we can help you when it comes to your data set, because different data sets work different ways. But this is the way that I chose to overcome that issue. Otherwise, I'd get an error. And then I added dot plot. So print it out, let me see what's going on. And this is our graph. So if we imagine that in this area is around January, because remember this data set starts January 1st, 2020, we had a high level of dissolved oxygen. And then as the pandemic went on, it dropped on down. The more people were at home. So we could draw some conclusions from that. We may be able to compare it to other things to actually prove a point, prove our hypothesis from stepping into our project. Now, keep in mind, I am not a water specialist. I'm just saying that I see a change during the pandemic when people are home. What that means, we'd have to come back and look at some other things to draw those conclusions, as well as talk to some of our specialists. All right. So this is Jupyter local. Let's get a little bit more complicated. Let's say either A, your computer at home doesn't have the capability to run the size data set that you need on your computer, or you just want something that's in the cloud so you can use those wonderful Google credits that you're being given for this event. And the way we can do that is through the Google Cloud Platform. Now, we have a training session that will be taking place in 2 weeks that will specifically target the Google Cloud Platform and give you a little bit more information about it. But just for instance, the way this works, you log into the Google Cloud Platform, you ensure you select the proper project. In my case, I'm using ODSAC. And then you search for Jupyter. And you'll see something come up that says Notebooks AI Platform. You click on it. Now, in my case, I jump right to the screen. In your case, you may need to enable it, and then it'll take you to the screen, and that's perfectly fine. You'll need to start a new instance. You select which version you want, and you go from there. The reason this is so powerful, is because of the amount of computing power you can put behind it. So let's say that someone decided to do some entry-level machine learning, because it takes a while to really train an AI set. But let's say you wanted to do some entry-level training using TensorFlow or Keras or scikit-learn. And you wanted to do it with GPUs, with NVIDIA Tesla T4s. Oh my goodness. So I can select that. And let's say that I don't want 4 GPUs. I want more. I want all the power. Those are the things that you can do with these different instances. So I can go to advanced options. And instead of only having 4 GPUs, I want mega mem with 96 virtual CPUs and 1.4 terabytes of RAM, plus the NVIDIA T4. Oh my goodness, because I want all of it. I want you to notice something here. I'll look up here in the corner now that I've selected that. A month in cloud computing time, if this machine was left up all the time, not even doing anything, just up, that could cost $5,400 a month, or about $8 an hour to run this. I say that because of this. If you don't need to use the mega mem machine, but you will feel more comfortable with something like the high CPU or even the N1 standard with 8 CPUs, you notice that amount comes back down quite reasonably. Use what you need, not what I would love to have in my house. I'll put it like that. All right, I'm going to go ahead and cancel out of this because I've actually already set up an instance. It does take a little while to set up those instances, and I've started it already. I'm going to open this up, and that will take us to Jupyter Lab. Now, inside of Jupyter Lab, this has the feeling of Jupyter Notebooks, but it's a little bit different. And that's because Jupyter Lab actually gives you access to a few other extensions like the Git repository and things you can add to it. But in this case, I just want to duplicate what I just did a moment ago. I'm not going to start a new notebook. I'm going to go to my file because I figured out that me running this locally won't work. I need more power. And so I've set an appropriate instance for what I need. Now I'm going to take this same local conda Jupyter file and I'm just going to drop it into our file manager. Click on it. And guess what? I have my same Jupyter notebook that I wrote locally now on a much more powerful machine so that I can do what I need to do. All right. Same exact code. Even the requests. So starting at the top, I can do a run. I can run the request. If you notice, the number started at 1 now instead of 4 like it did then. It's pulling down the data set. I can go to import OS and so on down the list. Again, this comes back to what Junyi said. You want to make sure that locally you've attempted to run it using the restart and run all to make sure that all of your cells are actually working together so that when you do bring it over, it will work and or you can start on this platform when you're working on it. All right. Now, the important thing that I do want to say, and if you notice, it did create the data set here so we can download that to our local computer when we're done. The thing that I do want to put out there is in using Jupyter Cloud, you want to remember to turn it off when you're done. As you saw, there's a cost associated hourly with running it. So if I close Jupyter Lab and I go back to my notebook AI platform, so the Google Cloud platform, I can select it and I can hit stop. Because I'm done using that, I am no longer being charged that amount. All right. So those are 2 that you can use solo. Let's get into collaborative. And the first collaborative project I'd like to show you is called Google Colab. And it's located at colab.research.google.com. If you have a Gmail account, you can access Google Colab. But the power of Google Colab is the fact that you can work collaboratively on your code. So in my case, I am actually going to go to upload and it says choose a file. I am actually going to use that same conda. Actually, I have a, if I can move you all are blocking my desktop. There we go. I have a Google Colab Jupyter notebook that I'm going to use here. Or at minimum, I will choose the file. Or I will start a new notebook and import it since it wants to be funny today. The power of demos, my friends, the power of demos. So I'll go to File. I want to upload a notebook. I'm going to choose the file. There we go. By dragging it in. And it opens up inside of something that looks similar to Jupyter. So this is a fork or a different version of Jupyter Notebooks. It still has the idea of cells that are text blocks. We still have our code that we can run. It even our code that runs, we can use Shift Enter just like we do in our Jupyter Notebooks instead of clicking play. So all of these concepts still work with the added bonus that I can go to share and include someone else in this project so that we could work together on it. Now there's a catch. Google Colab works with instances the same way we just saw in the Google Cloud platform. So if I click on files, you see that we have our files here, our data file that I just created. But with Google Colab, when this instance closes, anything that's not saved outside of this little space is gone. Let me say that again. In Google Colab, if you just leave your data in Google Colab itself and the instance closes, that data is lost forever. So you have to make sure that you save it somewhere. Now over in files, you can, of course, you see the Google Drive folder, but it says you need to mount the drive. Now I'm going to scroll down here to the bottom and cheat just a little. So this was a local conda version. If I go to, I click down here in this bottom cell, there we go, and I go to Google Drive, you'll see some code pops up down here from Google Colab import drive, and then it says where it wants to import. On yours, it'll also ask you to authenticate yourself, to select which Google account you want to use, and it'll have you copy over an authorization key and paste it in that will allow you to access Google Drive so that then you can save your files to Google Drive. Alternatively, you can also go to File, because we know for this event, you need to make a GitHub site. You can go to File and go to Save Copy in GitHub. You can save your code directly to your GitHub repository. So when I click on that, now in your case, it's going to ask for authorization and you need to sign into your GitHub account. But it shows all of your repositories. Now last week, I actually had one that I created called HPC in the City, Excellent Code. So if I wanted to select that repository, I have a name, my commit message, and I hit OK. And guess what? It'll drop me over into GitHub in my HP in the City Excellent Code. It has my file name and it saves my code to the repository directly there. Now, sometimes it does say, sorry, something went wrong, reload. But if you click on your repository, you'll notice that there it is, local conda Jupyter version or Google Colab version, depending upon what you just did. But you see, this was 22 seconds ago. So we know that this came from me right then, directly into my GitHub. So collaborative, direct access to GitHub or your Google Drive if you want, using Google Colab. And now for our last one. Our last development environment I want to tell you about is called Replit, R-E-P-L.it. Now, Replit is a little bit different. It's designed for a plethora of languages. So if I make this a little bit larger, I'm logged into Replit. It is again free. You can use your Google account to create a user. Well, if you notice, if I click on all languages, there are a lot of languages. Quite a few languages here that it supports, which is excellent. The other excellent thing is it's collaborative. Again, so I can, if I created a new REPL and I want it to be Python, and I'll give it the name HPC in the city and create. It gives me a nice IDE with main.py with my code here. And then it runs over here. But most importantly, again, it has that share button. So I can click on share and then send this link to anyone that I'd like to join my REPL. So for instance, right now I could click copy and go into Slack. And without telling him ahead of time, Josh, do you happen to have your Slack available? No? Boyd or Edgar, anyone have their Slack available right now? Edgar does? All right, Edgar, inside of Slack, and I'm gonna use the tax Slack for right now. I'm gonna find Edgar in my list. Actually, Edgar, I am gonna use the HPC Cloud Hack HPC. I'm gonna add the link here and drop that there. Now, see, I also know that Hector is here, so I'm gonna send that to him. And when I go back into REPL, they may need to set up accounts. However, they can join in the coding fund. So there we have someone that popped up. So who goes there? Let me do a print because we are in Python. Who goes there? I'm gonna run mine. This is Edgar. And this is Hector. And let's check to see if our code works. So I'm gonna stop. Let's play. And we see that that code indeed does work. Pretty neat, huh? One other thing. Now, we've been working inside of Jupyter for a little while. I'm gonna go back to my local Jupyter. I can't just take this code and drop it into REPL. So this is where the catch lies. REPL takes Python code directly, not IPython notebook code. But that's not a problem because we can go to File and download as, there we go, Python, so that we can use it here. Now, I've already done that. So let's make this a little bit interesting inside of our REPL. I'm going to take my code. I'm going to drag that there. So this is a download of the code. As you see, we have our import request. We have our information up top. All of this looks very familiar. And when we run it, we're going to get an error. Actually, I've already taken care of that error, haven't I? It's installing all the needed libraries. You can see that it just created our data set. Oh, not yet. Still going, still thinking about it. And sometimes this can take a little while, but eventually it'll actually run the program, add our file, our dataset file, because we're downloading it, and it'll add a picture. But the reason it'll add a picture is because I actually added a little bit of code that makes sure it actually saves it. So, in summary, I'll drop back to my, oh, there's Edgar, here goes, and there's Hector. So it's reading our main.py file. So the one catch we would need to do also is to save our code inside of that main.py or create a link or basically use this as a module or library for that program. Going back to our slides, which I do have. Let me go ahead and stop this. And let's share our slides again. There we go. So we have gone over a few different developmental environments. We took a look at Anaconda for local. We took a look at the Google Compute Cloud platform, so cloud.google.com, for an instance that we could create and adjust and make it as big or as small as necessary as far as in computational resources. We took a look at Google Colab that allows us to bring our teammates into a collaborative environment, ensuring that we save it to either GitHub or Google Drive before we leave. And we took a look at Replit, which allows us to not only use Python, but many different languages as our programming environment. So having said that, now you have a few more tools under your belt that you can use to help your team to function more collaboratively, as well as be able to begin to use that powerful Google Cloud Compute engine to power your project. So with that, I'm going to stop the recording and I'll be glad to answer any questions.